Assalamu alaikum, sir. I'm calling for student ID 2021160112. Today I'm going to talk about our VLSI project. Mm. I am from Group 7. Our VLSI project name is Smart Car Parking System. These are the members of our group. Now I'm going to talk about the state diagram. In our state diagram, there are five states. Basically, the first state is initial state or ideal state. The second state is whole state, which represents the taking password or asking for password state. The other states are incorrect password, correct password state, and the last state is in the state, in or stop states. Okay. When the reset is placed, when the reset is placed, initial state begins. If a car is sensed in front of the front sensor or entrance becomes one, then the system asks for password. If the password is incorrect, then it moves to the incorrect password stage. If it continuously gives incorrect password, it will loop around this stage. At whole stage, if and the password is given correct, then it will move to the correct password stage. In fact, in the incorrect password stage, after giving incorrect password and then giving a correct password, it will move to the correct password stage. Okay. Now, if the car doesn't process the back sensor, the exit remains zero, then it will stay at the correct password stage. If the car crosses the back sensor, the exit becomes one and it moves to the initial state. At that time, if a second car comes in front of second car comes in front of the front sensor, the entrance and exit becomes one. At that time, the second to stop the second car, it moves the second car to the end state. If the front car and in the entrance if the entrance and exit remains one, the car front first car and the second car is in front of the same both sensors, and then it will continue staying in the in the stage. If the back sensor car leaves, in fact the first car leaves the back sensor, then and the system moves to the whole stage, so that the second car can give its password. Then the uh, system continues accordingly. In fact, in the initial if the vaccine if a car is already in front of the back sensor and the same car comes in front of the front sensor, and then entrance and exit becomes one, and it directly moves to the in this test to stop the second car. Now, there are two lights to indicate stop or uh, express go. At initial stage, both lights turns off. At hold stage, for receiving password, the red light turns on. If the card gives wrong password, the red light stays. If the card gives right person, then the red light turns off and the green light turns on. When the second car comes in front of the front sensor, while the first car is in front of the back sensor, and then it moves to the in sensor and indicates red light. If the front sensor, if the first car moves away, it still holds the red sensor at hold mode. If the second car is the correct person, then it moves to the character stage. This was the state diagram for our system. Now moving Shikhar will going to explain the design SB5. Thank you.
Assalamualaikum sir, I am Mahmoud Al Mubin and my ID is 202116033. Firstly, we initialize the input. Inputs are reset, clock, entrance, and exit, and initialize the output. Where is green and red? Output registers are 3-bit indicator, and password is 4-bit length password, and we initialize the 5 step parameters. Parameters are correct password, incorrect password, initial state, hold, and end. Correct password are 011, incorrect password are 010. Initial state are states is 000, hold state are 001, end state are 100. and we register current state 220 and next state register 220. Register red temp and green temp. Initial begin, current state is initial state, and uh, then we show the loop of green and red. The green is the case current state one, case current state. Is initial state one begin, green are one, red are one, and indicator state are 000, and close the loop and hold are being green one, red one, and indicator are 001 state. Incorrect password being green are one and red are one when indicator is 010 state. Correct password begin when green one and red one indicator are 011 state. End. When end state is begin, green are one, red are one, and indicator are 100, and we assign the rate when red is start when red tail and green are green tail, and we close this loop. Then we then we initial statement is begin, interest sensor R1 and exit sensor R1, then it go to end. If else it when entrance R1 and exit sensor are off, then next state is going to hold state. And other and else when else next state are going to initial state. And whole state at begin. If password is correct password, our correct password is 1011, and this password is correct, the next state is correct password, and if it is wrong, next state is going to incorrect password. When incorrect password state is begin, if password is 1011, then go to correct password. If not, it continuously looping in incorrect password. Then correct password, start the begin, entrance are one, entrance are on, and exit are on. Next state is going to interstate LC when entrance are off and exit are on. Next state is going to initial state. And other side, next state is going to alternate correct password. And when end state begin, if entrance are on and exit are on, and next state are going to end, and next state on and other side, next state always go to old state. Trigger the next state and initial state in case. Then I'll close the loop, and here we reset all time reset. The reset is when follow car positive and reset positive or reset positive. If reset is start, current state is always initial state, and else begin in current state is always next state. And close the loop. Thank you.
So, sir, I am Arifur ID 20211610, and I am going to explain the test bench of the our smart card parking system relay code. And in test bench, first of all, we are going to declare 5 registers, which are mainly input registers, which is reset, clock, entrance, exit, and password. And our password is 4-bit password. And in this is for the output registers, which are green, red, and indicator. And then we are in this is the syntax of a test bench, which is car parking system UUT, clock reset, interest, and the following. After that, we are after that we are displaying a text which is welcome to our smart car parking system, and then the down file downwards, which is for the which is for the showing the output website, which is basically for showing the output website. And then the first test case, in this test bench we have used 4 test cases, and the last one is for resetting the machine. And we can also add more test case, but the code will be more complex, so we have used only one test case, only 4 test case. And in the first test case, the clock value is 0 and reset is also 0, instance is 0 and exit is 0, password 1001. And 10 clock means that the clock value will reset itself after 10-second unit. And the password in this test case is wrong. And after that, if else condition, which is going to display the state, and the
state is in the showing showed in the output, and this is the output for first test case one. And in this test case we can see that the entrance and exit both values are zero. The password is wrong and entrance and exit both values are zero, so the red light will also zero and green light is also zero, and the state will be initial state. And in test case 2, the we can see the clock value is 0, reset is also 0, entrance is 1 and exit is 0, and password is 1111, which is again an incorrect password. And 10 clock means the delay of a 10 second and the clock will toggle itself. After that, we are showing the message and displaying the case, and the output of this particular test case is here, where we are showing that entrance one and exit zero. And when the entrance one exit is zero, that means that means we are in a hold state, and now our machine will show that our machine will need the password, so it will hold the card. And in this case, the red light will go high and the green light is zero, and the current state is a hold state. And in test case 3, the clock is 0 and reset is also 0, entrance 1, exit 0, and the password is 1000, which is again an incorrect password. And up 10 clock means the clock is going to toggle its value after 10 units again, and then we are showing the message. And the output of this test case 3 is this, where the password is 1000 and the enter password is incorrect, and output are one. Output is red light is one and green light is zero, and the current state is incorrect state. And until the correct password is entered, the loop is going to enter again and again. And after that, here is the test case 11, means test case 4 to 10 we are not showing all these tests. We can show each and every case in making these test cases. In test case 11, we are resetting our FSM machine. In this test case, the clock is 0, reset 1, entrance 1, exit 1, password 1011, which is a correct password. And after this, the machine will reset itself, and the output is here, and the machine is resetting itself, and current state is again in the initial state. After this is the output of the web shell.
Assalamu alaikum. Now I'm going to explain our output wave. Here are the clocks. We have inputted 10 second delay. But this is the 10-second delay for the clock. Here is the password block. Password is given. There are four test benches shown. Four test cases shown right now, and this is the inference. Inference, well, initially the inference is zero, exit is zero. At that moment, green and red light will turn off state or don't care state. When the password is given wrong at inference one, think about the car is in front of the front sensor. The system will ask for password. If you give the wrong password, then it will trigger the red light. Right now it is triggering the red light here. If you continue giving wrong password, then it will continue triggering red lights. Okay. Then when the inference is one and exit is one at the same time, and the second car will face a red light here. The second car is facing a red light here. At a correct password. The first car has given correct password, and the second car is facing red light. Okay. We haven't shown another test case. You can it can be different test case can be added. The green light test case hasn't been added as our presentation is getting way too long. Now I'm going to talk about further steps. We can also add a counter to calculate the total number of cars checked in our parking system. Also, from the counter variable, we can calculate the total income gained from the parking system. Uh, and this was our whole project. Thank you for staying with us. Assalamu alaikum.